Okay, so let's demonstrate that this limit does indeed equal to 3. So here's what I'm going to use. We're concerned about what happens to this expression here as x approaches to 2. Okay, so to really separate, right, that this expression versus x is equal to 2, I'm going to say this is the same thing as x is equal to 2 plus some small number. That small number, I'm going to use the Greek letter delta. Okay, 2 plus delta, where delta is some positive number, let's say. Okay, some small positive number. This really says x is not 2, but something a little bit bigger than 2. All right. So let's replace x with 2 plus delta. Okay, so before I do that, this is factorable, so I'm going to factor it. Okay, so if you factor it, it's actually cleaner to plug in our numbers. Now when I replaced the x with delta, okay, so we get 2 plus delta minus 1. Right, 2 plus delta plus 1. I should technically change my limit now as delta approaches 0. Okay, as delta approaches 0. So delta is extremely small number. Now here this simplifies to 1 plus delta. This simplifies to 3 plus delta. Now as delta approaches 0, this expression is approaching 1. And this expression here is approaching 3. So the entire limit is 3. Okay, so that's why this is true. I know this is a little bit detailed. I know like most of you just want to plug in, let's say 2, and then 2 square is 4, 4 minus 1 is 3, so isn't that good enough? But this really tells the actual story a little bit closer to actually what's happening.